Hi everyone. So today I was going to start with transactions, but then I decided to do a little bit more practice on OLAP and do a Kahoot review of this topic before moving to the next topic. And so next session we'll cover transactions. And if we have time, I'm not sure if we have time next. I think we have class on Tuesday, right?
Yeah.
So last session will be Tuesday. So Tuesday we can do either a new optional topic as I promised. So we can cover several relevant topics, for example, which will not be included in your exam. For example, how to you learned how to, for example, create tables using SQL, but for example, how to import, for example, if you have a large file, or how to connect it to your application, things like that, or any other topic that is relevant. The other option is to do a practice session. So we can have a practice session like a combination of multiple choice questions in code format, something like that. And like half of the session you can do practice on ER model, star schema, SQL queries, whatever you decide. And yeah, so I think I'll get a survey to see which one to prepare. That is for next week. So today I'm going to do a quick review on OLAP and finish this topic and then do some practice. So we have talked about multidimensionality, and so we covered this topic also when we were covering data warehouse and star schema, and learned how we can use a star schema, for example, to analyze a measure based on different dimensions. Let me also see what is the problem and why you cannot see this. Project. Okay. And so we talked about multidimensionality. That was how we can analyze, for example, sales based on different dimensions. Could be, for example, location, time, products, and so on. And so, what was the data cube? So we covered several concepts last week. Data cube, slicing and dicing, pivot, so things that we covered. I just want to make sure you remember anything. So what is a data cube? Hello. So a data cube is a two-dimensional, three-dimensional, or n-dimensional object. So for example, if you have 3 dimensions, for example, to analyze sales, like for example, product, location, time. And then you want to limit your analysis to specific, for example, time period, specific, for example, products, and specific, let's say, locations. Then you can have a smaller cube, right? Which we saw here, right? So basically, this is a cube, right? So you can have, for example, this smaller subset of your data based on across these different dimensions, and we call it a cube. So how does it help? What is the advantage of using the cube? One advantage is faster analysis, and because the data then it's pre-aggregated, right? So it's a summarized pre-aggregated data, so it is faster for analysis. And so this was, for example, one example that we had, and we saw, for example, how we can have, on the left, we have a three-dimensional cube, right, across the three dimensions that I just mentioned. And on the right, we have different, for example, views that we can have, right? For example, we can have, and this is based on different years, right? For example, the one on the top shows for the year 2006, then 2005, and then 2004, right? And each of like these, what does each of these cells represent in the cube? Whatever you're measuring, right? For example, we are measuring sales across these dimensions. So each value, like in each cell, representing sale in that specific product, location, and time. And if you look at the these images on the right, it just shows them for a specific. Each of them shows it for a specific year, right? So, for example, sales value for only year 2006 across different locations and different products. And then we also mentioned about different OLAP or business intelligence tools features like slicing and dicing, pivoting, drill down, and roll up, which we covered today. So we already covered the slice and dice. Who can tell me what was a slice and what is dice? Yeah.
Slicing is like you look at like one kind of, it's like one dimension.
Yeah.
And then dicing is like you're looking across like multiple dimensions.
Yeah. So the difference is whether you are fixing one dimension and checking everything else for that specific dimension, or you are using different dimensions. And can you give me an example? In the context of the example we covered in class, for example, for analyzing sales, what could be example of slice?
A slice is like slicing it on 1 year, like I think you had 2005, 2006, 2007.
Mm-hmm.
And then a dice would be like a subset, like a smaller cube with multiple.
Exactly. So as you see here, so on the left you see slicing, in which you fix one dimension, right? For example, you can fix the year dimension, the time dimension, the product, or customer. And for example, if you want to, for example, analyze sales of your product across, for example, the entire products, entire customers, all products, for example, for a specific month. Here, the time dimensions is on a monthly basis. So you can have, for example, based on only 1 month or 2 months, right? So this will be the slice of your data fixed on the time. And dicing is looking at multiple dimensions. For example, here we get this subset, which is a cube, right? For example, for a specific product, specific customers at a specific time, right? And we had also some examples of slicing and dicing. And then we covered pivot. So we said pivoting is just rotating the current view of the data that you have. So it doesn't change the result at all. It is only for better representation and better visualization. Like, for example, let's say you have this table here showing, for example, sales in terms of the units sold for different stores across different regions or stores for different products, camping and footwear, for both male and female customers. So how many dimensions do we have here? 3 dimensions, right? We have the gender dimension, stores, and also product categories. And then if you, for example, see this, now we have camping footwear or product categories in the horizontal axis, and here in the vertical we have gender. So pivoting is just changing or reorganizing your data, right? So for example, if you pivot this so that you have the gender in the x-axis and in the y you have, for example, the product categories, does it change the value of sales? No, it doesn't, right? So still, for example, for the camping female sales 1, here camping female is 1, right? So the values are the same. Or for example, the sales of male at the store 2 for the footwear is 7. The same is here, which is 7. So the result is the same. The only difference is that when you have, for example, if you want to compare across gender, male, for example, versus female, it's just easier to compare them when they are side by side. So that's the only difference. And so today I'm going to also cover drill down and roll up, which is very easy. So in drill down makes the granularity of the data finer or more detailed. So what is granularity? Yeah.
Open down to your fact table is.
Yeah, how detailed you want to see your fact table. Recall the example we had in previous, previous topic of data warehouse. We had a table, detailed fact table, where each row or each record represented a detailed transaction, right? For example, if a customer bought the same product twice at different times, right? We want to capture that detail. So each row represents a unique transaction, for example. But then you can also have aggregated fact table, right? You can have a cursor granularity, which means, for example, if you aggregate different transactions that happen, for example, at different times by the same customer, same product, right? And put that in just one row instead of different rows. So in that case, let's say I buy a laptop. For example, and the price of the laptop, the item is the same, so everything is the same in that record. The only thing is that if I buy the same laptop twice, let's say once for myself, once as a gift, the transaction is at 2 different times, and these are 2 different transactions, right? So in the table, if you want to have a finer level of granularity, which means more detailed data, it means that you want to keep track of each transaction separately. You want to have access to each transaction at a specific time. But if you don't care about that and you just want to see, for example, the total, for example, purchase of a specific product by a specific customer, which is me, for example, how much I paid for the laptop, for example, for this specific item in total. And you don't care if I bought the same item 10 times, 20 times, you just want to see how much was the total, right? In that case, you can use aggregated or cursor level of granularity. And this is this granularity refers to the same thing. So drilling down means making the granularity of the data in the query result finer. You want to make it more detailed. You will better understand it with an example in the next slide. So moving down in the concept hierarchy or adding a new dimension to the queue. So always higher granularity means this is more detailed, or it is finer level of granularity. If it is cursor or if it is low granularity, it means the data is aggregated or summarized. Now, for example, let's say the query is for each individual store. We want to show separately for male and female shoppers the number of product units sold for each individual product in each category. So for each individual store, right? And we want to show the sale for both genders, each individual product and each category. So these are the 3 dimensions that we have, right? So this is the query 1 result. This is our starting point, right? Now we want to drill down this query, for example, in the dimension product. What does that mean? If you want to drill down this in the product dimension. So this is the product category dimension, right? What does it mean drilling down? I mentioned it means making it more detailed, right? So for example, under camping, in our original table, when we started this example, what are the subcategories, right? And then adding more detail under these categories. So for example, what are the subcategories under footwear? And also see that. For example, let's say if you have different types of footwear, for example, for the males, on the store 2, the sale amount for the footwear was 7, right? So 7 units sold was the amount of, or the units sold for the sale. Now, these could have different categories of footwear, right? For example, it could be, sport or any other types, and you want to see how many of them was for each subcategory. So it will be something like this, right? So drilling down on the product, which is this dimension, right, means reaching more details, right, or making it finer in terms of the granularity, or increasing the granularity of your results. So for example, for camping, now we have different types. For footwear, we have different types, and now we have more detailed information, right? Does that make sense? So this is just drilling down, and this is query 4 is just result of drilling down of query 1 on the product dimension. Now, this is an iClicker question. So, drilling down from camping to specific products like tiny tent means which of these options? So, I'm not sure if I started all. I guess multiple choice. Can you see it now? Okay. Do you need more time? Okay. So the correct answer, I'm not sure if I can, if the correct answer is marked, so you can mark it here. I'm not still very, oh, everyone answered this correctly. Okay, that sounds good. So the correct answer was option C. And because when you go from camping to tiny tent, which was what we saw here, right? From camping to tiny tent means from like a category to a subcategory, which means from a cursor level we are going to a more like finer or more detailed level, and so this is increasing granularity along the product hierarchy. And roll up is exactly the opposite of drill down. It is also called drill up. So it makes the granularity of the data in the query result coarser or less detailed, which is the opposite of what we have. So this time we have more detailed data representation, and we want to like get it aggregated and just reduce the granularity, right? So moving up in the concept hierarchy will reduce the number of dimensions. So for example, now if we have this, for example, table, and we, let's say, aggregate all of this into just one camping category, and the same thing for the footwear, aggregating all of them under the footwear category, which is this table here. This is drilling up or rolling up, okay? So this is the opposite of drilling down. So we just decrease the granularity of the result. So you can see here another, for example, query comparing the quantities of sold products, which is units sold here, on Saturdays, which you can access on the calendar dimension, day of the week, right? In the category camping, which you can access on the product dimension, provided by the vendor Pacifica gear, which is also on the product dimension within the three-state region, which is in the store dimension, between first and second quarter of the year 2013, which means we also need to access quarter and year across the calendar dimension. So we need to access our fact and also three dimensions. So just to see how the example query, SQL query, and this dimensional version looks like, this is the example. So the query returned one row per unique combination of product category, vendor, day of the week, quarter, and year 2013. So you can see that we accessed all of them, and we had to also join them, right? So we joined, for example, we have a calendar, store, product, and sales, right? And just these 4 lines are just for joining them. And then these are conditions that product, for example, vendor name is Pacifica, category name is camping, and so on. So these are just the conditions, and finally grouping by multiple columns. And when you group by multiple columns, it's just grouped by their combined values, okay? And so although like this query looks blind, right? And we said that we increase, for example, the query performance, and having, for example, multidimensional analysis should simplify the queries. The reason this looks a bit blind is just because our question was blind, right? But in general, it's still much better than having, for example, relational answering the same query on relational databases. Then you would have joined much more tables. So at least you have, for example, vendor and category tables in a category information in separate tables, which means instead of, for example, joining 3, you had to join 5 tables, right? So these are just some recommended video tutorials which I found helpful. So you can watch them later at home. And so far we were talking about OLAP, right? And we have different types of OLAP. It could be ROLAP, or a ROLAP, or MOLAP. So multidimensional OLAP is MOLAP, which means extending OLAP functionality to multidimensional database management system. Basically, it is just using the cubes. So what we have covered in terms of data cubes, those queries where we were seeing, for example, when we were used, for example, dicing examples, these are all MOLAP examples. So MOLAP is just storing data in multidimensional arrays, which are your actual cube, right? For example, the sale cube across the different dimensions. And so because the data are pre-aggregated, for example, you have sales on specific regions, specific customers, a specific time, or for example, other different dimensions, for example, across genders, products, and time, or any different combinations of dimensions, right? Depend on the query. So the data are pre-aggregated, which makes the analysis faster. And because we can also use a slicing and dicing, it can also make queries much more efficient. And so compared to our OLAP or ROLAP, which I cover next, here the queries are faster than OLAP, right? Just jumps to the next slide. And so what else? And another term here is sparsity, which measure density of data held in the data cube. Just referring to how much of the cube contains, for example, data versus empty cells. So, for example, if it has more empty cells, then the sparsity is higher. And then we have ROLAP, which means instead of storing data in cube, now we have another type of OLAP that try to keep the data in relational tables, similar to what we had in data warehouse, right? So a data warehouse and a star schema were still kind of relational schema, right? Similar to the relational schema we had before. Even in ERD class, you can select the relational schema to draw the star schema, right? So the only difference is that here you have more aggregated result and you have fact tables and analyzing, for example, the fact measure across different dimensions. Where all dimensions are directly linked to the fact, instead of, for example, relational schema in transactional databases, which you have, for example, many more, for example, more detailed tables connected to each other. So the purposes and the design are different, but still is relational, right? And it also follows the same properties. Like, for example, tables are linked to foreign keys, right? Your dimensions are linked to the foreign keys to your fact tables. Now, this is the difference between ROLAP and MOLAP, is that instead of MOLAP store data in the cube, now here we store data in relational tables, like a star schema, which we covered before, and we can use, for example, SQL to answer OLAP questions. And which one do you think among ROLAP and OLAP, which one do you think is better for large data sets? Which one do you think is faster? If you want to compare them in terms of their, for example, performance and flexibility, or for example, in terms of which one is, for example, better to handle large amount of data, which one do you think is better? ROLAP?
Oh.
ROLAP is better for which one? You can think. I'll give you a few seconds to think about this. So think about the features of ROLAP and MOLAP and tell me which one works well with large databases. Or for example, which one has higher scalability. Yeah.
I mean, I can see on the slide for ROLAP this is support for very large databases, but I would have said MOLAP because you said it stores data in like a data cube. So I would think, I mean, it depends on the query, but if they're already pre-aggregated, I would say MOLAP because it uses a data cube.
Okay, so we have to pre-aggregate them. If it's a large data set, then you need lots of pre-aggregations, right? Which again affect the performance. But if it's a small data set, of course it's faster to use MOLAP, right? Because then you can have these summarized data access them quickly. But if it is a larger, in terms of scalability, then ROLAP is better because it's relational and it just scales better, right? And so if for example, the ability to work with large, for example, data is more important for you compared to, for example, its flexibility or, for example, performance, then OLAP or ROLAP is your choice. Now, which statement, this is another question. So, which statement about ROLAP and MOLAP is correct? So everyone should answer this now. Ready? Okay. So let's see how many of you answered this correctly. Okay, 59% selected option A and 41% selected option C. So it was almost half and half. So the correct answer is option C, that MOLAP pre-compute summaries in multidimensional array. Now let's also explain the other options. The first option is ROLAP is faster than MOLAP for large data cubes. So MOLAP is generally faster. Okay, so it's generally faster because the data is pre-aggregated and summarized, right? But if it was only for the large, for example, and also with ROLAP, we are not using the cubes, right? We have relational tables. So MOLAP is faster, and it is also good for we are using data cubes for MOLAP, and the reason is because data is pre-aggregated and summarized, right, in the cube format. Option B says MOLAP stores data in relational tables, which is not correct. It stores data in cubes. Option C is correct. It says MOLAP pre-computes summaries in multidimensional arrays, which I just mentioned. And then ROLAP cannot support more than 3 dimensions. This is also not correct. It can have as many dimensions as, for example, dozens of dimensions, right? Because it uses relational tables, so we can have many dimensions. So MOLAP, just to summarize, MOLAP is type of OLAP that use multidimensional cube, right? It's generally faster because it uses pre-aggregated data and summarized data, right? And so in terms of, for example, query performance, okay, it's faster. But if you have, if you're adding, for example, new dimensions, your data is so large, you're working with large data set, then it has limited flexibility and not very scalable, right? It's more difficult to scale it versus, for example, ROLAP, which use relational tables. So ROLAP is also a type of OLAP that use relational relational tables or relational schema, right? And it's generally better for large data, and it also scales better. And here is just a summary of comparison between ROLAP and MOLAP based on different characteristics. For example, in terms of their design, we said MOLAP use data cubes versus ROLAP that use relational schema or star schema, right? And we had examples of this one. We also saw the example of this. In terms of database size, ROLAP can store large amount of data, but MOLAP is limited amount of data because we are keeping summarized data in cubes, right? In terms of data storage, ROLAP use relational database and MOLAP store data in array-based multidimensional data cube. And in terms of technology, ROLAP use complex SQL queries to retrieve data versus MOLAP, which we use, for example, matrix technology. In terms of speed, in general, MOLAP is faster, right? Because it's pre-aggregated data. And here is just a summary of what we already covered. So before we move to the Kahoot, so I also prepared the Kahoot including few questions about OLAP.